right, welcome back to another episode of Pollys Introduction to Computer Networks. And the announcements today contain definitely the regular video link stuff and the homeworks you need to turn in by Saturday. Now, what's new and exciting this week is this Exam 1. It's coming up. And to be exact, it's coming up next Wednesday. March 29th. Oh, okay. I can hear you're heartbroken. All right. So, hi, Yuchen. Hi, Chloe. Okay. So, again, in the exam, you'll be given the URL for the Google form, and the exam questions will all be on the Google form, and you just need to work on the Google form. But in addition to the Google form, you will be given also the URL to a Google Meet session. You need to join that Google Meet session so that Polly can see you throughout the exam. So, in order for you to connect visually, you will need to have a working camera and a good stable internet connection. And so, hey, what I suggest you do is after the lecture today, you think about your setup for the exam day. For the regular lecture, it might be okay with just your smartphone or a pad. For the exam day, you want to have a system where you have keyboards and a camera there for the Google Meet. So think about the setting for the exam day. Okay, and of course, think about the internet connectivity. Now, tomorrow, Wednesday, the first 10 minutes of the office hour will run a test. So you guys would try to join with your exam day setting. Okay? And Polly will acknowledge whether the camera is okay, resolution okay, the angle of the camera is okay. Okay, so that way, after tomorrow, you can focus on studying for the exam instead of wondering whether the system that you will be using for the exam day will be problematic. All right, so that should lower your anxiety a little bit if you come join the test run tomorrow. All right, and back to the lecture. And hi, I think mine is Mark and Kaishang and Sean, Glady, and Kelly. Okay, welcome back. All right, so the first set of topics will still be about HTTP, the protocol to support web browsing. Last week, we talked about the message format of the HTTP, and specifically the request message. And if you recall, the request message consists of three parts: the request line, and then header lines. There could be a variable number of these header lines, and then the data part. But typically for a request message, the data part is just empty. Okay. Before we start talking about the format of the response messages, there's just a very short video. Last week you hear about the request line. There's this command thing, right? And if you recall, get is a very commonly used command. You are getting a web object, so to speak. And you learn also that at the end of the very last video last week, there's also posting, post command. So these web forms, I'm pretty sure that the Google form you'll be filling is using the post command to upload. So the post command, the URL command, which is more used recently, there are actually a few more. So this very short video is to inventory these comments that you might see in the request line over generations of HTTP. And the last slide about HTTP requests here is quite straightforward. What it says is to tell you again what are the comments, possible in HTTP request line. In version 1.0, we see get, we see post, we see head again. But this is all that HTTP 1.0 supports. In HTTP 1.1, we extend the comment options from the three classic ones to add two more, put and delete. Okay, let's go through these three other comments. First, the head comment. So this is usually for a web client to send sort of initial HTTP request to the server, and server will send some response back, but only to tell the status of the server or the specifications of the web server, and leave the actual web object the client is asking for out of the response, so that the response is very short. And what's contained in the response messages are just all the essentials, like, what is the version of the web server program you're running over there? What is your IP address? What is the time date? What is the time date, the object that the client is asking for being modified last? Okay, things like that, the essentials about the server, about the object, so that when the client receives a response like that, the client can plan a little bit better ahead of time how the client does the requesting. Sometimes when the file is really large, the client might try to dissect and then do the requesting slightly differently. And put here, this one is actually quite forward, just to upload the file in the entity body of the HTTP request to the server, right? So in that request, we also specify which path in the server we want to upload this file to. Okay, so it's working pretty much like the FTP. If you recall FileZilla, you are dragging a file to the server, right? So it's uploading a file to a specific path on the server side. So put here implements file upload, delete, deleting a file. So FileZilla also allow you to do this. So essentially, HTTP 1.1 is to extend the original HTTP to include all the file uploading, downloading services, because the original HTTP only does file downloading, not quite the uploading. Now, when HTTP 1.1 is available, FTP protocol quickly loses its popularity. Okay? And that's why we rarely use FTP these days, because HTTP, the web browsers can do all these for you. All right, so this is HTTP request. All right, so now HTTP response. You know what? It comes also in three parts, but the first part called the status line. And then the rest are actually very similar. The header lines and then the data part. And now it's very common to have content in the data part in response message. This video is a little bit long. Stay attending to the video, because quiz 11 is coming right up after this video. Now, finally, the HTTP response message. Okay, the second type of messages defined in the HTTP protocol. You see here, generally, three parts. First, the status line. Second, the header lines. And the third, the data. So the entity body, so to speak, from here and down. Okay, and these are very similar to the header lines we see in request message. Each line, you see attribute and the value. Attribute and the value. Status line. 1, 2, 3. Again, 3 components. Let's go through each one of them as well in a bit more detail. In status line, first here, familiar. So the version of HTTP the server is implementing is the first component in the status line. Second, this is the status code. Okay. So in HTTP defines quite a number of these status codes. Each of these indicate a different condition. Okay. Some more related to the server, some more related to the object being requested. Okay. And for each of these status code, there's a status word being shown as well. That's the third component in the status line. So 200 here indicates okay, meaning the HTTP server is working well and the object you're looking for has been found. And it's going to come here in the body entity. Now, second part, the header lines. We see date. Yep, this is the date, time, the request is being filled, and this response is being generated. The server, this is an Apache server, version 2.0.52. Apache is one of the most commonly used web server implementation. Yeah, I think you heard about the other one, Nginx. So Nginx is certainly rising. Okay, it's not quite yet the most popular one. Well, let me clarify. By popularity, I meant the number of machines running a specific version of web servers. So Apache is still the most used web server. But if you count only the number of downloads recently, it might be Nginx. That's why you see I say that it's actually rising. So I think maybe in just a couple months, there'll be more Nginx server than Apache servers. Last modified, yeah, so this is to indicate when is the object you're downloading last modified. Oh, okay, it's a really long time ago. All right, ep8, what is this? This is actually, hey, for each version, okay, of the object that you are downloading, there comes also with a version number. So ep8 there is to indicate the version number. Nowadays, as you see, the HTTP protocol is not used only for downloading purpose. It can also be used for uploading. If there are multiple users there using different web browsers trying to upload the file, for example, poly and Caleb, the TA, tries to upload and override the grades Excel file, then you might have a consistency problem there. So the number here is to break tie, to make sure that a newer version does not override an older version or something like that, to resolve conflicts, so to speak. And accept range. Yeah, yep. So, you know what? Earlier when I mentioned the head comment in the HTTP request message, right? So when you send such a comment in the HTTP request message, the server responds with only the status line with the header lines, but without the data. Okay, so server there can actually tell the client, you know what, I'm a server that allows you to request content in terms of bytes. So the client there seeing this can then send the request more officially, instead of using the head command, using the real get command, and request to download byte 0 to maybe 1023 or byte 0 to byte 100. Okay, so you could do a range request in a way. And the server's next header line, content length. This is to indicate the size of the file or the size of the object that you're downloading. So you see the file size of the object is one critical parameter. Okay? If you're implementing a web server, you need to know a way to find out what the file size is or the object size is. Okay, the size is a bit messy. Let me clear the markups. Keep alive. Oh, good. This web server implements persistent connection. Okay, and so it indicates timeout interval is 10 and maximum 10 requests. So this is a persistent connection, but in the connection, it only accepts up to 100 requests. All right, so if it's more than 100, then you will force close. The server will force close the connection. So connection, keep alive. Content type, yeah, just like the client side header line we see. Yeah, the client accepts content of a certain format. Here, okay, this is to indicate the object the client is asking for, which format it is. And we see this is text-based HTML file, and it's coded in ISO AA59. Right? And empty line, indicating this is the end of the header lines. Right after the empty line, the data goes here. If it's an HTML file, then hey, text starting from here. Okay, the first file. So this is an example of HTTP response message. You see the structure is very much like the HTTP request messages. Next is just to share a bit more. HTTP response messages status code. We've seen earlier in the example 200 OK. This is saying request is successful, object is already embedded. 301, that means the server is saying the object is moved to a new location specified later in this message. So sometimes when you run into a message like this, you see, oh, click here. That's going to take you somewhere else. It's a redirecting link. If you see status code 400, that means your HTTP request format is not quite correct. Bad request. 404, that means the object you're asking for is not found. 505, HTTP version not supported. So in case you're using a very old browser, or if you're contacting a server that's very old, and yet your browser is implementing something newer, then you might not be able to communicate. The server is going to tell you this. Sorry, 505. All right, so quiz 11. So pollys will switch to the whiteboard quickly so that you can see the markup. Good. So many of you might see that quiz 11 is very similar to quiz 10, but this time we sniffed a reply message. And here it is. Okay, so you can probably identify where the status line is and where the header lines are, and from where we see the data. So Q1 asks, was the document found successfully? So a reply must be corresponding to a request. So a client requests for an object, requests for a doc. The reply should indicate whether the doc, okay, is found. Q2, how many bytes are there in this document? Oh, the size of the web object. Okay, can you see it in the sniffed message here? Q3, what are the first 5 characters of the actual object? All right, this quiz should be rather straightforward. So guys, let's move to Discord and go to the week 5 quiz 11 channel. Wait, okay, so Loretta here has already posted the solution. Yeah, so you see, it's quite straightforward. For those who are following the video, it should be rather straightforward for you. So let me give you just say 3 minutes. Okay, so grab your teammates or just quickly type up what you find solution for Q1, Q2, Q3 are, and let's go. Yeah, so hey, very straightforward, right? So you guys all get it right, and some of the teams also pointed out how come, right? They know that the doc is successfully found, And some actually point out that how did they discover the object size, as well as how do they know the less than exclamation mark DOC are the first 5 characters. So this is the delimiter between the header lines and the data part, isn't it? Okay, great. And so now we get to move back to the second topic. So we are not quite yet done with HTTP. Next, Polly will try to emulate a web client and trying to interact with the real web server using this protocol called Telnet. So Telnet is for remote logging. It's very similar to SSH that you're using to connect to the PA workstations. The difference is just that SSH is a secure connection. Telnet, insecure. Therefore, you get to see the plain text that are being exchanged between Polly and the web server. So the first video tells the setup. So what I will show you in the demo coming next is to do this. Telnet to the favorite web server here. And we're going to use this machine here that the textbook author has set up for us. So we'll telnet to gaia.cs.umass.edu at port 80. Okay, what it does is to open the TCP connection to port 80 where there's a server already running, a web server already running. And anything typed in will be sent to port 80 at this guy. Okay. So Telnet is a remote logging application, just like SSH or RSH, if you know what it is. It's another remote logging command for native Unix users. All right, so Telnet is very, very old. Many operating systems probably doesn't support it anymore. But I've already installed it on my Mac, so we're going to show that in a little bit. Now, once we telnet to the web server, and we'll type up some things. Okay, let's try typing this. Get path name and file name as the argument for the get command, and then the version of the web browser. So we'll be pretending that the telnet here is a HTTP 1.1 client, and host gaia.cs.umass.edu. All right, so header line. So essentially, we are trying to do a human web browser, okay, by typing online right here an HTTP request message. So once we are done with this, we hit return, okay, and then we hit return again. Needs to have a what? A \r\n here in order to complete the HTTP request. All right, so the whole thing is going to be like this. And yeah, we'll see what pops up in return, what the server there at umass.edu sends back. Okay, let's not sniff the traffic. Let's just look at the response coming out of the Telnet program. All right, so let's switch to the demo mode. All right, let's Telnet to gaia.cs.umass.edu at port 80. All right, connect it to gaia.cs.umass.edu. Now let's pretend to be a web browser. Get. Oh, wow, that's pretty long. The path and file, pretty long. Let's copy it from the sides. And over here and print. All right. And then host poly.ntu.edu. How about that? All right. And one more empty line to indicate this is the end of the header lines. There we go. Wow, it's returning a lot of things. Scroll back, and scroll back. Wow, very long in fact. But it looks like it's an HTML file, right? It's an HTML file. This is a hyperlink to an text HTML file. Okay, let me scroll a bit faster. I don't know how long this is. Oh, there we are. Yeah, so we typed up this line here. Okay, and we also say we are host poly.ntu.edu.tw and an empty line and then return again. the whole message gets out to the web server at gaia.cs.edu and the web server returns this http/11 to the 200, okay. And header lines, number 1, the date. Header line number 2, the server. Oh, it's an Apache server. And X power by PHP, I see. Content length, content types. And hey, empty line to indicate this is the end of the header lines. And starting from here, the real body. Okay. So we get the output of calling this PHP query at this path. Let's see, interactive problems, computer networking, a top-down approach. Oh, okay. So this looks like the main page of all these interactive exercises that we see every now and then on the slides. All right. So there, essentially very text-based interaction between the client and the server. As human beings, we could also do it right here, right now, online as a web browser. All right. And I think let me just go back a little bit here. You see here, 200 is a very classic example of, hey, the syntax defined in an application layer protocol. In HTTP, to be exact, 200 is to indicate OK. So OK here is just to say it explicitly, the semantic of 200. Right? So that concludes the messages format, semantics, and syntax of HTTP. All right. So yeah, Polly did notice that I say, yeah, okay, a lot in the videos. By the way, guys, those videos are recorded the first time Polly started doing this. Okay, you can see that Polly was overacting a little. Very interesting. It's funny that Polly look at it now. But hey, let's come back to the lecture. So cookies. This is the next topic, and it's a very important topic now. I'm sure that you guys have experience already doing online shopping. So what you do is you get an account, and then once you get that, you log in with the username and password to the shopping site. And you might browse through a few products and make purchases. In the end, you quit the web browser. But after a while, if you start the web browser again without logging out previously, you might find that, hey, going to the same shopping site, you simply remain connected. You don't have to do logging again. But how can that be? Because if you recall, HTTP is a stateless protocol, which means the server should not know who the clients are and having no a record of the previous visits from the same client. So this is obviously a behavior of a stateful web server. You know what? HTTP does not allow stateful behavior. So what's allowing the stateful behavior is this thing, cookie. So this video, it tells the mechanism of cookie. Next, cookies. Yeah. Many websites these days will try to prompt you to set up cookies before they allow you to visit the website further. So it's very, very relevant to our everyday life. Let's see how it works. Okay. First thing is, the cookie setup process is always initiated from the website. So meaning from the web server that your web browser is requesting objects from. So web server there is going to send a message to the web browser carrying a special header line. Okay, it's the cookie setup special line. And the web browser there, upon receiving such a message, it's going to generate, okay, a corresponding message if you click OK to insert cookie. And that message is going to carry, again, a special header line saying cookie OK. All right, so exchange of messages between cookie setter and cookie allower. Now, when you say, OK, I will allow setting of the cookie, your browser is going to add an entry to the special cookie file on your local disk. Okay, so that is exactly what's expressed here in the special cookie setup line. And when the server receives the message allowing cookies, server would then add a special entry as well to the backend database. And that entry set up here and here will actually map to each other, allowing the server to identify who you are and when have you visited the website last time. Okay. Let's use an example to explain. It will work slightly better. Let's say Susan always accesses internet from her PC. And she's visiting a specific e-commerce site the first time. In the initial HTTP request, okay, that arriving at the server, the site will then create a unique ID, okay, and that will be an entry being added to the backend database. Right? So that ID is going to be carried. Okay, in the message, the site sends back to Susan. So that's going to be set cookie and then the number created here. All right. So local hard disk you have there, or Susan has there, will have that entry, okay, set up in the cookie file. So this will go back to the server, okay, carrying also that special ID that Susan has already allowed to set up. And then at this point in time, the server would finally enter the entry to the backend database. So that's the way it works. Let me illustrate, okay, and so that you know clearly what's going on. Client, server, or Susan, Amazon.com. Okay. Now, at the client side, you have this special cookie file, and it's managed by the web browser. And you might have clicked OK to eBay. So eBay has already set up a cookie entry, carrying unique ID ep8. Server here has a local disk as well. It's maintained more as a backend database instead of just a simple file. Right? So, but when you visit the website, Amazon.com the first time, you send an HTTP request message. Now, of course, you have not yet been in Amazon before, so there's no entry for the Amazon website. Okay, so in your initial HTTP request message, there's not going to be any cookie special header lines. All right. So when Amazon.com here receives HTTP request, of course, it will try to grab the objects that you're looking for and try to generate the HTTP response with it. But in the meantime, it will be creating an ID, okay, for this particular user, okay, and add that to the database. And in the response, it carries the web object that you're looking for, but it also carries the special header line, the set cookie line. Okay? And hey, see, the ID created is carried over through the HTTP response message back to the user. So, web browser here sets up one extra entry saying, hey, for Amazon the website, use ID 1678. So for the subsequent visit, subsequent browsing, all the HTTP request messages is going to carry the cookie OK and I am a user 167A header line. Right? So here the server, of course, will be generating the web objects, generating the HTTP response message that you're requesting with the request message. So response message. But the response message might also contain additional content. Okay? Server there could be seeing your browsing history a couple clicks back and discover that, hey, you might be looking for a specific item, okay, and then recommend potentially items you'll be interested. Okay, so that might also be part of the response messages. So showing the items you are looking into buying as well as related products. Okay, so for example, if you're looking to purchase a phone, then the website might be recommending a phone case, okay, or a number of phone cases. So what's amazing there is 1 week later, okay, when you come back and try to purchase something from Amazon again, okay, the first request message you'll be sending will already be carrying the cookie entry. Okay, so once you have it set up locally on your cache file, on your cookie file, for all the subsequent HTTP requests, it's going to by default carrying the cookies. Amazon here will know, yeah. So over time, the server will know probably your profession, probably your income level, things like that. Okay, so that's why it gives people a certain creep about setting up cookies, and you might be warned, be careful about setting up cookies there.
Yeah, so hey, aren't you concerned about having these cookies around? So yeah, indeed, cookies. On one end, it brings convenience, so you don't have to log in again and again. But on the other hand, It allows the server side to track all your browsing activities, and so they can infer approximately what you do, you can count level, etc. So this next video is to discuss the trade-off of using cookies a little bit more.
Now let's discuss cookies a bit more. We're going to talk about the trade-offs of using cookies. First, the cookies from a business perspective, from a website's perspective, is actually quite convenient. So you see, you can authorize the users quite easily, okay, by looking at the ID in the cookie header line. Tracking the shopping carts as long as the ID is the same, right? This is items purchased from the same user. You can recommend items so that the users will go, wow, cool, that is exactly what I was looking for next, right? If the user is purchasing a phone and the website suggests purchasing of a phone case. Yeah, and browsing emails, yeah, you will not want to try to log in and type up password again and again. You want to be able to maintain that email reading session, email sending session over time and log in just once. How? Very nicely through the cookie line in the HTTP request. Okay, quite convenient. Okay, otherwise, you guys, including Polly, when I read my Gmail, I have to log in again and again and again. There's no way we could live like that. Right? So convenience. But on the downside, those websites would be able to learn a lot about you. Okay? So you store emails, that's pretty much your personal life. You store your purchases there, that's pretty much also your personal life. Okay? So over a long time, you can imagine Google, Amazon, Facebook, all these major websites, they know a hell lot about you. That's why people are freaked out so much about these big sites, okay? Allowing them to set up cookies, allowing them to store information about you, okay? So downside, privacy. Okay. Now, another perspective is more technical, keeping states. Now you see, hey, there's ID on the local cookie file. There's ID stored at the server side, the backend database. So server and clients are now storing states of each other, about each other. But some of you might go, hey, wait a minute. Didn't we talk about HTTP being a stateless protocol? And what's nice about stateless protocol is that, hey, none of the endpoints need to store anything about each other. Okay? No storage requirement. And you don't have this problem where, hey, if the connection between the client and server is broken, and you might have these inconsistencies in the states they maintain for each other, right? You have to reconcile and resolve conflicts. And that is actually a very, very hard problem, okay? Who do you trust more, the server or the client? Okay, sometimes it's a bit hard to say, okay? So cookies here, you're seeing is, in a way, a hacking HTTP such that we can maintain states, because HTTP was not designed in the first place to maintain states. But then now with the cookies, we have this issue potentially between the client's cookie file and the server's backend database. What if, the entry is inconsistent? Then you might have an issue as well. So trade-off in terms of usage, okay, in terms of privacy concern. Trade-off in terms of technical difficulties maintaining the states.
All right, so that was cookie and the discussion. The next two topics, local cache, web cache. So this is about caching the web objects we have downloaded previously. Because if we want the same object again, we don't need to really go through the internet to get them again. So this is a way to save internet bandwidth, to save also delay. There was a question during last video, but this was about cookie. So Mark was asking, so a website might send you cookie, but you can decide whether you want to use this cookie or not. Yes, you can actually disable the cookies selectively or enable the cookies selectively, setting your browser. Bing Chen was asking, if we clear the cookie files, next time when we visit the website, would it generate a new pair of cookie? Yes, I think so. Bing Chen. If it works like this, seems that the old cookie ID and web server will never be used again. Well,
think again, Bingteng, it really depends on the design of the server. If it's a shopping site, you see that if you recall, you usually generate an account. So by logging into the account, yeah, the company might associate the cookie you had previously with the cookie you now acquire. Okay, once you have the account, nowadays you are pretty much sharing a lot of what you do online with these major websites. Yeah, that's life. Okay, guys, learn to accept that. Do you see that many of these services that you enjoy from the web is also free, but there's not really free lunch. So the cost, I'm afraid to say this, is partly from your privacy. All right, so let's move on to the next topic. Hey, caching the web objects. That's a way to make the internet more efficient, passing these useful information. And the first one is called the local cache. And Polly might be repeating in the video, what is the purpose of cache? The next two topics are more about trying to reduce traffic between the server and the client, or trying to reduce the delay downloading a certain object. It's called the caching. So what cache means is to store a temporary copy of certain data. Okay. So conditional get here is like to have a local cache of the web pages that we have downloaded previously. Okay. So the goal is to not send the object again and again and again if the copy we're storing here is already the latest. Okay. Because as a result, we don't need to send the object, and that reduces the delay, and we also reduce the bandwidth requirement. Okay. And so saving the bandwidth is going to be good for everybody. So the way it works is this. Okay. So the first time the client downloads a web page, it's going to keep the copy of the web page on a local cache. So that's somewhere in your local disk. And in the meantime, we record the date, okay, the cache copy is downloaded. And so that when we send a request for the same page again, we carry this special line in the header field, the if modify since, and then the date, okay, of the cached copy, the day we have requested the copy the first time. And then at the receiver side, at the server side, the response will contain the no object if the cached copy is actually the most up-to-date, meaning if the copy at the server has not been changed after the date, then there's really no need to send it again back to the client, okay, because the copy right here is already the latest. So in that case, a special HTTP response message is going to be sent, and the status line is going to read like this. Yeah, 304 not modified. And in the body of the HTTP response message, it's going to be empty. Okay, so no need to send the object. And the way it works is more like this. Let me illustrate. The second time, the client here requesting for the web object sends request message and having this in the header line. If modify since the date the page was downloaded the previous time. And if the server finds that no, it's not yet modified, then send back a short HTTP response carrying the status line. And that's all. No data here. But otherwise, if the object is modified, then we send back a regular HTTP response that says 200 OK in the status line and the web object, the web page again, okay, in the body and the T. All right, so now you see what we meant by local cache. So that web object is stored locally on the web browser end. Now, next is web cache. So we store the web objects in a third party called the proxy server. So it's not the original server, it's not the client, so it's actually a third party. So here's the mechanism. Web caches. The purpose is very much like the local caches, but the way it works is somewhat different, but not much different though. Okay. The main difference is this. In local caching, we keep a copy of the object here. Okay. But now we keep a copy of the object here in the web cache, or also known as the proxy server. Web cache or proxy server. Okay. And in conditional get, we still need to send HTTP requests to the original server. It's just that the original server decides whether to send the object with it or not. in the response. Okay, sometimes yes, sometimes no. So we save a little bit delay and bandwidth this way. But in web caches, the goal is actually trying to satisfy some client request such that there's no involvement of the original server required. Okay, so some of the clients doesn't need to reach the original server to get the object. And this is done by keeping a copy of the object somewhere in the middle at the proxy server. Okay, so the way it works is this. Users will set the browser such that for all web access, let's go through the web cache. So subsequently, the browsers will send all HTTP requests to the web cache. So send it to the web cache. If the object, the page we're looking for, is already in the cache, proxy server sends the object back. So you see, it works somewhat like a server, but it's not the original server. It's somewhat a delegate of the original server having a copy here. Okay. So object in the cache, cache return objects. Otherwise, the cache here, the web cache here, would request from the server a copy of the object. So this request will be like, the proxy server here behaving like a client of the original server. Web cache there, request object from the original server like a client. Okay. And after the object is downloaded here, the proxy server then sends the object back to the requester. So let me illustrate. If the object is not here, request go to the original server, response comes back, store a copy, and then forward it back to the client. And what's nice about this is, look at this client down below. If the client is requesting the same object, it's a hit here at the cache. Server here sends back the object directly without going through this segment of the internet. So, cache there acts both like a client and a server. As a server, so that it serves the original client, the objects. As a server, because if there's a miss, it will be requesting the original server for a copy of the object. Right? So, some of you might see already, right? A web cache like that is actually preferred by the ISPs, okay, which serves a whole bunch of customers locally. Usually people sitting close to each other tend to prefer fetching or tend to fetch similar content. Okay? So a lot of times ISPs might encourage you to set a web cache on your browser. Now let's go through a few examples to detail why using web caching. Local cache, nice, reduce delay, reduce bandwidth. Through this set of example, let me take you through what is the benefit of doing web caching. In a nutshell, a lot more delay and a lot more bandwidth saving.
All right, and we won't have time to go through this example to demonstrate why we want to do it on the proxy server. Okay, so this will be all we have for lecturing today. And come tomorrow early, 10, and definitely stay for the office hour, the first 10 minutes, so you can test out your camera. Okay. If you have any more questions, feel free to type up. And if you have not yet completed the Quiz 11, please do come to the W5 Quiz 11 channel to fill it up. But otherwise, that's all for today. I see you tomorrow. Okay, bye.